Welcome to the second week of the coding class. So in the first week, you will remember that we saw the basics of computer and programming, and we saw how to install Python and how to basically set up the idle. And we also saw how to write a basic Hello World program. And you will remember that we saw how to write comments, which are basically a way of telling Python that we want something not to be interpreted. And we also saw the variables and data types, the basic ones, and we saw how to do some basic operators. So in this second week, we are looking at these brew topics, and the topics we are covering today are taking inputs from the user. So if you remember last week, we were hard coding all the inputs. We were assigning the values to our variables, and we were like coding all those data into our programs. Now in this week, we will take a different approach, a rather more practical approach, and we will be attempting to get all these inputs from the user. We will also learn about the strings, and we will learn about the lists in Python. And then as a bonus topic, we will get into the control flow, where we basically learn about if and else statements and what we can do with it. And by the end of this week, you should be able to write a calculator like application, which basically takes inputs from the user, which may be the number they want to do operations on and which operation they want to do. And then you can write a bunch of if statements to check whether the operation they wrote is addition or subtraction or multiplication. And then you can give them the answer depending on the numbers they gave and the operation they choose, which is basically how the calculators work. Now, the first thing we are looking at is the input. So the input is a built-in function which allows us to accept input from the user. So the syntax, we want to write the keyword input followed by parentheses. And then inside here, we want to write a message which is called the prompt message. And it's nothing more than just a message you want the user to read, which will give them an idea of what they should type into this area. So Python will not read this message we put inside here. It's not relevant at all. It just informs the user what to put here. So this is an example of the input function in use. I declare a variable name and then I set it equal to input and I open close brackets and then I give a useful message to the user. So what will happen is this line will prompt the user to enter their name, and once they do so, it will save that name on the variable called name. And the thing to be really aware of is that inputs are always accepted as a string in Python. So if someone entered their name, it's by default a string. Now, when the program is executed, what will happen is you will get a screen like this. So you remember I say this message is only to help the user know what to put in this area. So that's exactly what happened. That message which we pressed inside our input method is displayed on the screen, and then you will have a ticking mark here, which basically tell you that you can actually type in this place. And when the user types something here, it will be stored on the variable name. So basically the user will type their name here and it will be saved under the variable name. Now once we have that data, we can do so many cool things with it. After receiving the name, for example, I can go ahead and display it with a nice greeting. I can say greetings plus something, which we will actually see about it in the strings. So this user, who happens to be me, has entered their name as Adrien, and then the program will print greetings and it will add their name. So if I was to enter a different name, then I would have a different name here. So as you can see, this is a whole new approach of working with our programs because now they are usable to the users. We are not hard coding the value of a name. Instead, we are asking a user to enter it and it will respond based on the input they put in. Now, since we saw that all the inputs are strings by default, what if you wanted to take an integer or a float as an input? So in that case, you would need what is known as casting. And casting is nothing more than specifying a type on a variable. Suppose I had my variables a and b, which appears to be numbers, but as if you were cautious about last week, you know that these quotation marks here, they tell us that this is a string. So the program look at these two as strings. In fact, if you attempt to add them, you will literally get what you would get by taking a text and pressing it just at the end of another one. So you get 12, which is pressing 2 after 1. Now, this is not what you would want in most cases, by the way. Now, if you want these to behave as integers, you need to cast them to integer. You need to specify a type on them, and you can do that by using the int method. So when I say a is equal to int, and inside here I press a string, this will go ahead and attempt to pull out an integer from this string, if it's possible to do it. So now after doing this, casting both a and b to integers, now if I add them, I will get 3, which is what you will be looking for in most cases. So we have this int method to cast to integer, we have the float, and we have the string. If I had a number like 1 and I want to have it as a string, I could always cast it to sta, which is string. Now, having this idea in our mind, if we want to take inputs from the user, which are numbers, then we can simply wrap that whole input sentence into an int statement. So after grabbing this edge from the user, which is going to be looking something like this part here, then we will attempt to convert it into an integer and we save it to edge, and that will work out very beautiful. Now, this takes us to the second subtopic of this class for this second week, which is strings. So as we saw, strings are always defined by using these quotation marks. And with Python 3, you can use either double quotes or single quote. So every time you enclose something in quotation mark, it's a string. Now, there are a couple things we can do with strings. Actually, we can do a lot with Python strings. First thing to know is if you want to access something from a string, then you will want to specify its index. Let's say now, for example, I have a, which is this word, and I want to print a certain character from this word, and I don't want the whole word, I want a character. Now, if you want a character, of course, you have to tell Python where is it located, like where should I find the character you are looking for. Then if I write a and I use these brackets and I specify what is known as the index, then by using that index I can tell Python the location of the character I want. If index is basically the position of a character. If we count from 0, at what point do we reach the character you want? So this is saying give me a character at position 0 in A, and this is give me a character at position 1 in A. Remember that we always count from 0 in programming. So the first character has index 0, 1, 2, 3, 4. That's like the most important thing to know here. Now we can also extract a certain portion of a string. Let's say I don't want just one character. I want like to extract maybe this portion of the string. I want to pull it out. And if you want to pull it out, intuitively you can think that, okay, I need to specify from where do I want to cut and until where do I want to cut. And you can beautifully use this slicing method, which is specifying from where, the starting point, and the ending point. This means cut out a slice from A, which begins at index 1 and finish just before index 4. Notice that this is exclusive. For the closing index is exclusive, the opening one is inclusive. So we go from 1 and we stop just before we reach 4. So index 0, index 1, index 2, should maybe use the Roman, index 3, and this was going to be index 4. This is index 3, by the way. Now, just before we reach index 4, we will stop. So we pull out this part, and this is basically what stricing is all about. Now we can also use negative indexing. Negative indexing is simply counting from the back. So suppose I had a very long text and I'm looking for a certain piece of information and I know it's very likely to be near the back. There's no point in counting from the front. I could just begin from the back and we will see how we can do that. But for now, know that if I use a negative number in front of a negative number, it will basically mean count from the back. And when we count from the back, we begin from index minus 1, which is the last character. Now we have another function called arrayn, which is short for length. If you had a string and you wanted to know how long is my string, how many characters does it have to be more technical? So you would use arrayn method, and the way it works is simply you write the keyword arrayn, open and closing brackets, which is basically how we call all the Python functions or methods. And then inside you press the variable you want to find the length for it. So this will work very beautifully for strings. You see, I tried it and I got 3, which is the length of this string as you would expect it. Python has so many built-in functions for strings, which we also call string methods. Some of them include strip. Strip, basically what it does is to get rid of all the empty spaces in front of a string. So I had this string which had like several empty spaces here, and suppose I want to get rid of them. I would just use a.strip, and then I always remember you have to use the brackets to invoke to call a function. And this would go ahead and remove all these empty spaces and give me what is remaining after that. This would be useful, for example, in a case where you have a login system and you don't want someone to be denied login just because he accidentally added an empty space in front of their name or their password. But it's more complicated than that, but you would imagine that if someone put in their name and they add a few empty spaces in front of their name, then it would be really nice if there was a way to recognize that and not punish them for it. So strip method will basically solve that. Now there is a dot lower and dot upper. As you would imagine, dot lower just puts everything to lowercase and upper puts everything to uppercase. If you have used Gmail, you may have noticed that if I type someone and I begin their name with a capital letter or a small letter, it's always going to work. And the reason why it's able to work is that you can imagine that it has something like this running at the backend. So I type in my name, and either the whole name is converted to a lowercase string or an uppercase string. That way, if I write a capital letter or a small letter, it's always going to find the person I want. It's not case sensitive. So the way to build something which is not case sensitive is to convert everything to either uppercase or lowercase. Now we also have this method of replace, which basically replaces a certain character with another one or with another piece of information in a string. And the way it works is it needs two inputs or arguments. The first one is what do you want to replace? The second one is what do you want to replace it with? So here I replaced B with double Z. And as you can see in the place where I used to have B, now I have double Z and everything is just the same. Okay. Now another interesting method for strings is called split. Split is when you want to cut a string. And when you want to cut a string, you need to define how do you want to cut it. So the easiest approach we do that in Python is basically specifying what is called the delimiter or a separator, which in this case I use the comma. So it simply says, take my A string and cut it everywhere you find a comma, and give me all the pieces of like all the segments which I obtained by cutting it. So it will take A, start reading it from the front, going all the way. I meet a comma, or I have to cut at this point. So it cuts. Then it will again go until the end, and it will give me what is called the list, which has basically all these pieces of information. You can use anything here. If you want, for example, if you had the wrong sentence, you would want maybe to see which words make this sentence. You can cut it everywhere there is an empty space, which would be equivalent to leaving empty space here. And it's what Python does by default. If you add nothing inside here, it will split everywhere there is an empty space. Now, the next topic is called string concatenation. And this is really just, it may sound complicated, but it's as simple as uh, joining strings rather. Suppose I had the string which was my first name and another one which is my second name, and I wanted to join them into one full statement. So it's as easy as adding them. Remember when, as I said earlier, when we were talking about the, I think it was where, let me see again. When I was talking about the numbers, and I was telling you that if you don't convert them to the strings, it will actually go ahead and perform the concatenation. Yeah, it's here. Yeah, this point, remember when we said A plus B, it just took B and added it after A. This is the idea of string concatenation. And that's what now we will look more formal here at this point. If I try to get back, yes. So you take A, you add C, which is an empty space here, and you add B. I simply added an empty space because I didn't want N just coming after A without any empty space between them. Okay, so you use a addition sign and you can concatenate your strings. Now the next thing is called string formatting. Now you saw that with concatenation we just basically attach a string at the end of another. Now, what if I wanted my string to contain some data, some custom data, which could be defined by any user or obtained from somewhere else? So how do I insert the variables inside the string? Now the solution to that problem is what is this, which is called string formatting. And in Python, there are multiple ways to do string formatting. There was an old way which used the what did that signs, I guess. Yeah. And but now we have like two modern ways which are really much more cool and more powerful. One, which is this method one I have here, is called string formatting. It's basically is using sorry, it's called using the format method. So basically, what you do is you have your string here, which I'm trying to type here. I am and years old. I'm basically trying to say I'm maybe Adria and I'm 100 years old. So what you will do is where you are typing your string, you want to leave the curly braces marks everywhere you plan to be plugging in your variables, and everywhere is really important. Now, when you finish typing your string, which is at this point here, you will call this method dot format. This dot is important as well. I think this might confuse some people, so I will remove it. You call dot format, and when you call dot format, you basically press inside the variables you want to be inserting into these locations. Now, the thing to be really mindful about is, since you have just been leaving a mark of everywhere you want to be plugging in variables, it's important that you put your variables here in the same order which you want them to be inserted in. So this will say, okay, take name, plug it into the first sign which I left in my string, which happens to be here. So it comes and plug in name. Name, remember, is equal to Adri. Now the second is age. Age, press it, plug it into the second curly braces. So it plug it inside here, which is 100. And it will give me basically what I wanted here. So just remember to follow the same order. And remember to close both the bracket for the format method and for the print method. Okay. Now, second method, which is much more recent, and it's only available from Python 6 up. If you're using lower versions, you might not have access to this. It's called f-strings, and basically, it's much more straightforward. You press F inside in front of your string to inform Python that you want to do this is an F string basically. And then as you are typing your string, now you don't just leave a mark of where you want to be plugging variables. Instead, you just plug it in on the go. So you carry braces, inside them you plug in the variable name, and you basically keep doing that until the end. Now Python, when it reads F, it will know, okay, this is an F string. Every time I meet this, I will automatically find this variable and put it inside here. And it will do the same for H, and you have your string as desired. This is, you can see this is much more nicer, and it's shorter, and it's more clean to see. Quick recap, we saw how to access elements in a string, how to do slicing, how to count from the back, how to obtain the length of a string, how to get rid of the empty spaces in front of a string, how to put all the letters to lowercase, to uppercase, how to replace a character with another, and how to concatenate strings, and how to do formatting using both format and f strings. And this basically ends the section about strings. Now you may go ahead and try to see if you can remember what all these methods does and practice them. And now for the second part of our class of today, we are looking at the Python lists. So the lists are really useful to store data which is related. For example, if I had a class of students and I wanted to store all my student names, I can imagine using a list to store all the names of my students. A list can contain integers, floats, strings, other lists. It can contain anything, really. And the cool thing is that the data which is stored inside the list is changeable. So I could say, okay, the data which is at this point, change it to something else. That's not something we could do with the strings, because strings are immutable. Immutable means they cannot, you cannot, we saw we could replace, but when you replace, basically what it will do, it's basically to create a copy of that string with one character replaced. So it doesn't really modify that original string that much. It's basically creating a copy of it. But with lists, we can change all the data as much as you want. It's like the most flexible data type in Python. Now, when we have our strings, we can use the length method, indexing, slicing. All these methods can be used in the same way we're using them for strings. Now, for example, let's say I have this list, and if I print it, I get it as it is. If I want to grab something at index 1, remember index 1 is here because we count from 0, 0, 1. So if I say give me something at position 1, it will give me 2. If I say give me something at position -1, it will count from the back and give me the first one. The same, I can slice a portion, and I can also get the length of my list. And as we do string concatenation, we can also add two lists together like this, and it will basically place the one list at the end of the other. Now list has other interesting methods. The first one you're looking at is append. Append is the one I find myself using quite too often. And what append does is basically to take a new element and add it at the end of the array, the list, or rather. So suppose I had this list and I wanted to add a new element, which is to append it. I will call my variable numbers dot append. This is the method you want to be using. And inside here, I will place what do I want to append. So next time I print numbers, you see 6 has been added to the end of the list. So always remember, you call append and you put whatever you want to append. I can append a string like this, I can append another list, I can append anything. Okay. Now on the contrary, you see append we always add at the end. What if you wanted to add something inside here at some specific positions? So if that's the case, then you want to perform insert, not append. So with insert, you can get to specify the index where you want to insert your element and then the element. So I can say, for example, numbers.insert index 1, put 5, then it would press 5 here. At index 1, it would press 5. So this is what insert would do. Now we saw that the data are changeable with lists. So the way we change data in a list is you basically grab an element. We saw how to get it using index, and you set it equal to a new value. That's as easy as that. Now suppose I wanted to change the first number to 500. I grab it, numbers index 0, and I set it equal to 500. And the next time you print numbers, you will have your first element changed to 500. The next method we'll look at is called pop. As the name suggests, it's basically to pop off the last element inside in a list. So if I say a is equal to numbers dot pop, it will take numbers, pop off the last element, and store it at the variable called a. Next time I print numbers, 5 is gone because I popped off something. And remember we saved it to a. Now I can actually try to see what a is. A is 5. That's what we got from the pop operation. Yes. So pop removes the last element on the list. Now we want to look at the a quick summary of all the list methods. So with the list method, so there is append, which adds an element at the end of the list. Clear, we didn't practice it, but it basically removes all the things. You can go ahead and Google these methods. The other is like nicely available on Google or Stack Overflow. And we have copy, which basically gives us a copy of a list. We have count, which counts how many times something has occurred. So if I was to say numbers dot count 5, I press 5 inside here, it would tell me how many times 5 has occurred from this list. Now extend is the one we have a look at when we are dealing with some quite sophisticated operations, but it basically take a list and add it at the end of another one. It's more like add. Now index, we use index when we want to know at what position is something located at. I would say numbers dot index 5. I would be saying, okay, what index is 5 located at? So it will go through my list, and the first time it meets 5, it will give me that index. For example, suppose you had a system which store the time, which store like the time at which your students got into the class or your workers got at the job, and everyone when they turn into the class, maybe they type their name somewhere, and you wanted to find out which student arrived on the fifth place. So you would say, oh, maybe let's say you wanted to find out uh, like when did student Bob come to the class. So if I say index Bob, it will tell me, okay, Bob is at index 5 in the list of students, which means Bob was added at the fifth position. Okay. Insert, we saw what it does. Pop, we saw. Remove, it removes an element. So you do like numbers dot remove 5. So it will go through the numbers and it will get rid of 5. Now for the sort, sorting is basically as the name suggests. If you sort numbers, you will have them in ascending order by default. So if you have like 157 and you perform the sort, you will get like that would be sorted already by the way. Okay. It's basically getting the numbers to an ascending order. And it's always a good idea to take a quick pause and Google this method. If you type Python sort in Google, then you will find really nice examples of how sort is used in Python. And now the bonus topic of today is called the control flow. And I personally think, and I think I'm right on this, I think if else statement is the most important part in programming because all the softwares we use, even this I'm using to present now, they're all built on this core logic of if else. And what if else statement is basically is you are telling the computer how to behave in different circumstances. A good example which I used in today's class was suppose you had a kid and you were sending your kids to go to buy some maybe some food from the food store or from the town. You would tell them, okay, go to seller A and try to find sugar from seller A. If you don't find it from seller A, then maybe try to go to seller B. And if you don't find it there, A's if it's not there, try to go to seller D. Now, at the end of all these statements, you would want to tell your kid what to do if he doesn't find sugar at all, and that's where the else statement comes in. So the else statement, it's basically telling your program what to do if the condition was not satisfied. So the condition was, okay, if seller A has sugar, buy it from them. If seller B has sugar, buy it from them. Else, which means if none of them has sugar, just buy something else and come back. Maybe that's not a very good example, but that's basically what it would be. So, as a quick example here, this is actually a valid program in Python if you had this as a built-in methods. So I'm saying if tired, this is a pseudocode. It's not a real code. It's a code-like statement. If tired, sleep. Else, work. Although some people will still work even if they are tired, but a normal person will rest if they are tired. So if tired, if this condition is met, then sleep. Else, keep working. So this is the fundamental idea of almost all the programs you interact with. So if this condition is satisfied, then we go inside here and we perform whatever is on this block. If the condition is not satisfied, however, we will skip this whole part and we will jump to this part, the else part, which is what we should be saying here. So how do we write the if-else statement? First of all, we write the keyword if. I write my if here. Next, we write a condition. So my condition would be something like if trader A has sugar, then I would write a semicolon. Notice this is very important. I write a semicolon and then I press enter. Now, when you press enter in your idle, you will notice that Python, for the first time, I think, you will be noticing this. It will have like this indentation. Indentation is basically this empty space which is here. By default, it's set to 4 spaces, and now you will begin to appreciate why I briefly talked about configuring our idles so that we have the same expected behaviors. So by default, Python will skip 4 spaces for you. And 4 spaces are by default equivalent to one tab press. If you press tab, it will leave 4 spaces. Now, the reason why this indentation is so important for Python is that's the only way Python knows like the block, where does the block starts and where does it end. For example, if I had 5 lines here, maybe do something one, do something two, do something three, all those lines would have to be parallel on this line. That way, Python will look, okay, if it goes inside if and check everything which is on this line. So all the 5 lines would have to be vertically parallel and with the same indentation. Now, when I get rid of the indentation, now Python, okay, now this is a new block starting. And you can see this else is parallel to the if. So if in case this condition is met, we do whatever is on this level. Else, we go inside else and we do something else. So don't try to remove this space because if you remove it, Python will not be able to tell that you have this block inside else statement. This is different from many other programming languages which uses curly braces to basically wrap everything you want to be executed. I think this Python approach is more user friendly because we don't have a ton of curly braces going around everywhere. And this actually forces us to write our code in a very readable manner. You can imagine a block of code on this level and a block of code on another level, and that's really nice to see and to work with, especially as your code become more complicated. Now this is an example of an if-else statement. I defined a variable name called Tom, and I said if name is equal to Tom, print login successful, else print access denied. So this basically means, okay, check if the name is equal to Tom. Remember name we use double equal signs. And if that's the case, then print login successful. If, however, that is not the case, print access denied. Now, when I run this program, I entered Y. I mean, like, oh, I had my name set already as Tom. It's basically hard coded. And when I ran the program, it printed access denied. And the reason did that is it came here, check the condition. Is the name equal to Adria? It's not because name is Tom. If this condition is not met, Python will not even bother checking what is on this block. Even if you have 1,000 lines here, it will not. It will skip them all and jump to else statement because the condition isn't satisfied. Now it jumped here and printed access denied. Now in another more practical example, you would not want to have just two possible scenarios. You would not tell your kid, okay, go to trader A, check if he has sugar, if he has it, buy it. If we don't have it, just return back home. You would want those other possible case scenarios. You would be like, if A doesn't have it, try to go to B, try to go to C. If they don't have it, try to go to a new area or try to buy something else. You would want like so many else if statements. So the way we write else if statement, we use elif, which is a short for else if. Now in this example here, I defined a teacher's name called Bob, and I defined a student's name called Alice, and I also asked someone to enter their name, and I save it to the variable name. Now I check if their name is equal to Bob. I know it's teachers. It's a teacher who is trying to maybe log in or open the door. Now you print, okay, welcome teacher. Now if the name is Aris, then what I will do is I will print, okay, welcome student, because Aris is a student. If it's neither of this, which means this condition is not met, this condition is not met either, then really there's no choice left. That's why we write the else statement. So if none of these two is satisfied, just jump here and print not recognized. And when I ran this program, I entered Aris, and when I entered Aris is student. So it checked here, is name equal to Bob? No. Don't bother check this statement, just jump down. Else if name equal to Aris, oh now this is the case. Then print you are a student. And once it finds something which works, there's no point in checking else statement. So this program basically stops here. It doesn't bother check the else statement because this condition is met. There's no point in going down any further. And this is basically how the if, else if, and else statements work. And it's important to realize that you can always nest these statements to check for multiple conditions. You can say, okay, if name is Bob, I will insert another if statement inside here which check if maybe password is correct, and if it's correct I will tell them you can log in, something like that. You can always write as much complicated as logic as you want with if else statement, and I think this is the core of programming, being able to write these control flow statements. We will see how much things we can build from these simple ideas, and I hope you will really enjoy writing if and else statements. Now, This basically brings us to the end of our second week, and in quick review, we talked about taking inputs from the user, we talked about strings, and we talked about lists. And as a bonus topic, we talked about the if and else if statement. Now, congratulations for completing the second week of our programming course, and I have a few exercises for you. The easy one, I suggest that you definitely should do this because this will show you whether you understand the topics. If you want a bit more of challenge, try this, which is the question I had at the start. I think everyone should be able to do this if you review the material. And if you want slightly more challenge, you can try this. So read it and see if you can solve it. And I have written a nice code here to motivate you. This was basically the founder of Apple, Steve Jobs, who said he believed everybody in the country should learn how to program a computer because it teaches you how to think. And this is absolutely true. This is absolutely perfect because you will see how much your thinking capacity can really increase as you learn to code. As you write if and else if statements, you will really come to appreciate how true this code is. So thank you for following all the way up to this point. Let me know if you have any comments, and I will try to read the comments. And yeah, if you find this useful, you can like this video or share it with your friends. And I will see you in the week 3 content. Thank you so much.